Okay, in this video, we're going to talk about functions in section 2.1. Definition: a relation is a set of ordered pairs. The first entry can be of each ordered pair corresponds to the second or of the ordered pair for relation to exist. Consider the relation was born on. So I've got a group of names along with the dates that they were born on. Okay. And pictorially, I've got a set of people and a set of dates. And I drew the arrows connecting each person to the date that they were born on. So is this a function? Well, Andy and Nate have the same birthday, May 3rd. Is that a problem? Let's read. Let x and y be two non-empty sets, then a function from x into y is a relation that associates with each element of x exactly one element of y. So, is this a function? Yeah, is a function. Each element of x is going to one element of y. Now the fact that Andy and Nate have the same birthday, that's okay. Each person has only one birthday. Nobody has two different birthdays. That's impossible. Each person only has one birthday, so yeah, this is a function. Okay? In another example, suppose that we have these set of points. 9, -2, -3, 5, and 9, +2. This would not be a function because 9 is going to two different places, 2 and -2. You can't have that with functions. Each element has to go to exactly one element in y. Okay? Function notation, usually denoted by the letters f, g, and h and others. F of x is the value of f at the number x. The domain of a function is the set of all possible input values, and the range of a function is the set of all possible output values. As an example, f of -1 is equal to 5, f of 0 is equal to -3, f of 1 is equal to -1, and f of 2 is equal to 5. Let's write f as ordered pairs and give the domain and range. F is a function, by the way, since each element of x is going to go to exactly one element of y, -1 and 2 go to exactly one element of y. They happen to go to the same one. That's okay. So f is the set containing -1, 5, 0, -3, 1, -1, and 2, 5. The domain, we got -1, 0, 1, and 2. And the range, we got 5, 3, -3, and -1. Okay? So, definition, if it's possible to solve an equation of y in terms of x, then we write y equals f of x, and we say that f is given explicitly. An equation is an implicit form when it is not an explicit form. Here's an example, three examples. 2x plus y equals 3 is an implicit form. When you solve for y and f of x mean the same thing. So f of x equals -2x plus 3, or y equals -2x plus 3. Now you're in explicit form. If I add y and subtract 6 from both sides, y is equal to x squared minus 6. Y and f of x mean the same thing. So f of x is equal to x squared minus 6. xy is equal to 3 means that y is equal to 3 over x. Y and f of x mean the same thing. So f of x equals 3 over x. Now we're in explicit form. All of the functions that you'd be given in using function notation are going to be things that are written in explicit form. Although sometimes you do have a function and it's something that's not in explicit form. Okay, now not all equations define a function y equals f of x. If an equation is solved for y and more than one value of y is obtained, then the equation does not define a function. So here's an example. Is x squared plus y squared equals 1 a function of x? What type of equation is this? This is a circle that is centered at the origin, 0, 0. X minus h squared plus y minus k squared equals the radius squared, is the general formula. H and k are both 0. R is 1. So if I solve this for y, y squared is equal to 1 minus x squared. Y is equal to plus or minus the square root of 1 minus x squared. It's not a function, okay, because of the plus and minus there. We know for each input, there's only one output. Okay, for each input, there's not this or that, which is what we have here, a plus and minus. In general, circles are not functions. So let x equal 0, then y is equal to 1 or negative 1. So 0, 1 and 0, negative 1 are on the graph. Okay. Here's an example. F of x is equal to 3x squared minus 4x minus 2. Let's compute the following here. F of 3, f of x plus f of 3. 3 times f of x, f of 3x. F of negative x, negative f of x. F of x plus 3, and f of x plus h minus f of x all over h. H is not 0. We call this the difference quotient of f. And then part I, the domain of f. Okay. Part A, f of 3 means that I would replace x with 3 and simplify. So I've done that. 3 squared is 9, times 3 is 27, minus 12 is 15, minus 2 is 13. F of 3 is equal to 13. Part B, f of x plus f of 3. Well, f of x is this equation written 3x squared minus 4x minus 2. F of 3 is 13. So all I got to do here is add 13 to the end of the function, combine my like terms. 3x squared minus 4x plus 11 would be the answer. Okay, part C, 3 times f of x. Well, f of x is 3x squared minus 4x minus 2. So I'm going to multiply each of those by 3. I get 9x squared minus 12x minus 6. Now that's different from f of 3x. F of 3x means replace x with 3x everywhere. So I've done that. 3x squared is the same as 9x squared times 3. You get 27x squared. Minus 4 times 3x is minus 12x minus 2. Notice how these are not the same thing at all. Okay? Sometimes they are. I get that. But most of the time they're not the same. Okay. Part E, f of negative x is 3 times negative x minus 4 times negative x minus 2. Negative x squared is the same as x squared times 3 plus 4x minus 2. Now negative f of x means negative the whole thing. Negative the quantity 3x squared minus 4x minus 2. I can distribute the negative into those three terms. And so I get negative 3x squared plus 4x plus 2. Now notice how these are not the same. Sometimes they are. I get that. They're not here though. Okay. Part G, f of x plus 3 means that I need to replace x with x plus 3. X plus 3 squared times 3 minus 4 times x plus 3 minus 2 is what I get. 3x squared minus 18x minus 27 minus 4x minus 12 minus 2. So that gives me 3x squared. 18x minus 4x is 14x. 27 minus 12 is 15, minus 2 is 13. Okay. Part H, f of x plus h minus f of x all over h. Well, f of x plus h means that I got to take the original function and add x plus h, just like what I'm doing right here when h is 3. So I get this part, 3 times x plus h squared minus 4 times x plus h minus 2. Okay, now I'm supposed to subtract f of x. Subtracting the quantity, 3x squared minus 4x minus 2. Make sure that you got parentheses around that. And this is all over h. Okay, x plus h squared times 3 gives me 3x squared plus 6xh plus 3h squared. Minus 4x minus 4h minus 2 minus 3x squared plus 4x plus 2. Some things canceling here. So the 2's are gone, the 3x squareds are gone, and the 4x's are gone. And that leaves me with 6xh plus 3h squared minus 4h all over h. I can take this a step further by factoring an h out of the numerator and canceling it with the 1 down under. And that gives me 6x plus 3h minus 4. And this is as simplified as I can get it. So we call this the difference quotient of f. And the difference quotient is really just where you would draw a line and measure the slope of the line. Okay? We'll talk more about that coming up here. Part I, the domain of f is all real numbers. Okay? In other words, this function, I'm asked to take any number, square it, multiply by 3, subtract 4 times that number, and subtract 2. I can do that to any number. There's no problem with that. Okay. When did I stop right there?